Okay, in this video, we're going to look at our inverse trigonometric forms. And we'll look at how to use it and when to use it. And you have a worksheet which shows you all the different types of integration that we deal with some instructions for each. Again, this is all review stuff you had last semester. So let's try an example here. For our first example, I want to look at the integral of 2 divided by the square root of 1 minus 4x squared with respect to x. And of course, when I look at this, I first try to see if this will fit a basic rule. It will not. There's no basic rule that's a fraction other than exactly 1 over x. I look to try u substitution. If I were going to do u substitution, the u would be 1 minus 4x squared, which means I would need a negative 8x. And even though I can get a negative 8, I can turn that 2 into a negative 8 by multiplying on the outside by the reciprocal of what I need. I cannot get an x. It is not a trigonometric form. It is not a partial fractions. It is not an integration by parts. So that leaves us either with the inverse trig or the trigonometric substitution. In both of these, we're going to pick our pieces the same. U is going to be what we have to square to get the function piece. So the u in this case is 2x. A is what we have to square to get the number piece, so the a is 1. And then if we look on the top, we see we have our u prime. And anytime we integrate the form u prime over the square root of a square minus u square, this gives us the inverse sine of u over a plus c. So in our case, we simply need to come over here and put in the pieces. This is going to give us the inverse sine of our u, which is 2x, over our a, which is simply 1, all plus c. So a very simple case of using inverse trig forms. Let's try one more here, and it's going to be a much more complicated case because if you remember, there were lots of tricks that we could do. So in our second example here, let's consider the integral of 2x divided by x squared minus 4x plus 7 with respect to x. And so, of course, I'm going to go through my process. The first thing I try to do is fit a basic rule. And again, you can split the tops of fractions to turn things into basic rules. You can do long division. But the only fraction that we can do with a basic rule is exactly 1 over x, which we do not have here. So let's try u substitution. If I were going to do a u substitution, the u would be x squared minus 4x plus 7, which means the u prime that I need here is going to be a 2x minus 4. And remember in the past we saw that we could always get numbers. I've got the 2x on top. The only thing I don't have is the negative 4. Well, I can go ahead and put in a negative 4 as long as I also do the opposite of that, which would be to add 4. But when I do that, I have too much on top. So what am I going to do? I'm going to come in here and I'm going to split this into 2 separate integrals. Reason being, remember we can always split the tops of fractions. So this actually becomes in the integral of 2x minus 4 divided by x squared minus 4x plus 7 with respect to x plus, and I'll just put that 4 on the outside, the integral of 1 over x squared minus 4x plus 7 with respect to x. And so now we have created 2 separate integrals. And so what we want to do here is we want to go ahead and look at each one individually. This first integral looks like it is simply, very simply, a u prime over u. If our u is exactly what we saw, x squared minus 4x plus 7, the u prime we need is 2x minus 4. And we know if when we integrate a u prime over u, we simply get the natural log of the absolute value of that u. So this piece is going to give us the natural log of the absolute value of x squared minus 4x plus 7. Let's go ahead and look at our second integral here. No longer can we do a u substitution because we don't have the x's. It is not a trigonometric integral. It is not an integration by parts. And we cannot use partial fractions since we can't factor that denominator. That leaves us with either the inverse trig or the trigonometric substitution. And trigonometric substitution would involve radicals. So it's got to be an inverse trig. In an inverse trig, you're going to need 2 pieces. Always need these same 2 pieces. You need a function piece that's being squared and a number piece. So I don't have my function piece that's being squared, but if you remember, what's one of the tricks we can use here? we can complete the square. In doing so, we'll form a perfect square trinomial, which will give us our function p squared. Okay, so let's see how this works. I'm going to bring down the plus 4. And then I'm going to go ahead and write this as the x squared minus 4x, and I'm going to leave some space there and put that plus 7. And the reason I want to leave some space there is I'm going to complete the square on this piece here. In order to complete the square, I'm going to take 1/2 times the coefficient of x and square it. Half of -4 is -2, and -2 squared is a positive 4. So I'm going to add 4 here, and I can only do that if I also do what? Subtract the 4. So I'm going to subtract the 4. Now in doing this, I have guaranteed myself that this piece is now a perfect square trinomial. Let's see what that looks like. I'm going to leave this first piece and carry it down in my final answer. But what I have here is 4 times the integral of 1 divided by. Since this is a perfect square trinomial, it will always look like x plus or minus some numbers squared, and then you can combine the plus 7 and the -4 at the end to give you a plus 3. And the number that goes inside of here is whatever you got on the inside of this thing you squared. Half of -4 was -2, so what's going to go in here is a -2. And now I have the pieces and parts I need to come in here and do a trigonometric or an inverse trig. The u is what I got to square to get the function piece, so the u is going to be x minus 2. The a is what I got to square to get the number piece, which in this case will be the square root of 3. I see that I have my u prime on top, and when I have u prime over u squared plus a squared, that is going to give me, and I'll write this in a format that you can see it, it's going to give me, of course, the 4 is going to carry down, but I'm going to get then 1 over a times the inverse tangent of u over a, and then we'll do a big plus c at the end. And so let's go ahead and put in our values here. And I'm going to flip a page, so just bear with me for a minute. Okay, let me come in here and bring down our first piece. If we remember here, we had the natural log of the absolute value of x squared minus 4x plus 7, and then we were going to bring down the plus 4, and when we'll put 1 over a and multiply that through, that's going to give us 1 over the square root of 3, leave some space there, times the inverse tangent of our u, which was, I believe, x minus 2 over our a, which is the square root of 3. Again, leave some space there, plus c. And why did I leave space? Well, we are not allowed to leave the square root of a number in the denominator. We're going to have to rationalize those denominators, and we do that by multiplying those by the square root of 3 over the square root of 3. So that our final answer here becomes the natural log of the absolute value of x squared minus 4x plus 7 plus 4 square root of 3 over 3 times the inverse tangent of the square root of 3 times x minus 2 over 3, all plus c.